All right, so tonight I'm excited to introduce Alexis Bernal. She's currently a researcher at the Scott Stevens Lab of Wildland Fire Science at UC Berkeley, and she's contributed to a number of new applied research projects related to fire ecology and management, forest health, and historical forest reconstruction. I'm sure she'll talk about some of her more recent paper contributions, and I have shared those in some of the links in the emails out to everybody. But with that, Alexis, as long as you're ready, I will pass the mic to you.
Yeah, thank you so much, Cordy. I really appreciate it. Thanks everyone for joining me tonight. I'm really excited to speak with y'all because as much as I love the research that I do and being out in the field, what I really people about the work that I've done and trying to get the research that I do, but have it be more applicable to like real world management decisions and such. So as Cordy mentioned, I'm going to be talking about managing forests for resilience, kind of at the landscape scale mostly, and talking about what resiliency means and what that looks like from a management perspective, from what we can see about the types of resilient forests that are expected, especially under climate change. So I think the most important thing to do right out of the gate is to provide my definition of resiliency, because that definition is what I use to analyze and interpret the research that I do. Resiliency is a pretty sexy term right now, and it's thrown out there by a lot of people. But like everything in ecology, there's a lot of hand waving and not necessarily a really solid answer for what resiliency actually means. But that's the fun thing about it, is that you can make it what you want, but as long as you're transparent and definitive about what you mean, because transparency in research and science is super important to me. And so I want to make sure that each of you understand what I mean and where I'm coming from when I'm talking about managing forests for resiliency. So I see resiliency as a summation of two components, resistance and recovery. And I define resistance as the ability for a forest to withstand a disturbance. For example, a forest is resistant if we have 100% survival following a wildfire. And then recovery is more of the ability to rebound after a disturbance to some defined disturbance state. For example, you may have high overstory mortality following a wildfire, but substantial regeneration replaces that population. And so here in this slide, what I have up here, as you can see, is while resistance and recovery are components of resiliency, they're not necessarily positively correlated. I see their relative contribution to forest resiliency as more of a spectrum. And so I'm going to kind of explain what I mean there by looking at these arrows here and showing some examples of what we think of in terms of resiliency from a recovery and a resistance standpoint. When we talk about resistance, that includes like low overstory mortality following a disturbance, and typically low regeneration following a disturbance. An example of that is this picture here, where it shows a Jeffrey pine forest on the east side of the Sierra Nevada. Typically in those types of forests, productivity is pretty limited. So we see little fuel accumulation over time, so it's pretty resistant to fires. It's able to withstand fires pretty well, but we also see slow growth, and as you can see in this photo, very little Jeffrey pine regeneration. But in these ecosystems, so productivity is pretty limited. And then here, on the other hand, we have forests that can change pretty substantially following a disturbance. So an example here in this photo is like a lodgepole pine forest, and we typically think of those as stand replacing sort of fire regimes where there's complete overstory mortality following a wildfire. But what we do observe is like very high densities of regeneration, as you can see here in the foreground where there was a fire and regeneration came after. And generally in like these types of forests, the productivity is typically very high. So fuel loads tend to be pretty high, which makes them less resistant to fire hazards. But that's why recovery is so much more important than resistance, because they've evolved to sort of replace those populations if given enough time. But in between the sort of resistance recovery spectrum, what we find is like the fire-prone mixed conifer forest. And I think that that's like most of the places that we typically, like myself, that we live and we work in. And so according to this sort of working definition of resiliency, we see that these types of forests kind of fall in the middle, where yes, productivity can be pretty high, but that productivity is typically limited by major disturbances, in this case, fire, frequent fire. And it's really a balancing act where beneficial fires can limit the amount of biomass that can exist at a particular site. So again, resistant to fire, but it facilitates regeneration in these like heterogeneous patches where small scale, high severity can provide opportunities for new cohorts to establish and thrive, and can do so because, again, these sites typically are pretty productive. And this is kind of the fire-prone mixed conifer forest is where I'm going to be focusing this presentation around mostly. Again, because these are the types of forests that we commonly work and live in. But I also fully acknowledge that maybe that's kind of a little bit of a cop-out from my end, because this is the same forest type that I pretty much do all of my research in. But even if you're living or managing an ecosystem that is very different from what I am talking about, the ecological principles remain pretty much the same. Things like disturbance regimes, climate change, adaptations, and the considerations of those things. And so we have to ask ourselves, you know, what, not only like what resiliency means, but what is resiliency, you know, why do we want it? What does resiliency look like? And does promoting that align with my objectives for the forest that I'm managing? And so now that we have this sort of working definition of what resiliency means against components, resistance, and recovery, why would we want resiliency? And while this may seem like a pretty basic question, I mean, of course, you know, we want our forests to be resilient, but the reasoning behind resiliency is a little bit more nuanced in that it's based on some pretty fundamental ecological principles. And what I mean by that is that resiliency is achieved when we are able to maintain the integrity of an ecosystem. Essentially, it's how it looks and how it functions. And the most popular way to achieve this resiliency is via restoration treatment. Restoration is an attractive approach because it attempts to mimic the selective pressures, in this case, disturbances, large-scale disturbances that drive evolutionary history. So essentially, if disturbances selected forests that were resilient to those disturbances, then we should desire to mimic those same structures and compositions so that our forests are resilient to future disturbances. But what does resiliency look like? Well, our best guess can come from the historical record, where we can find information on forests, what they look like prior to Euro-American colonization. So the figure that you see here in this slide is from a paper that I worked on with Malcolm North, where we looked at operational resiliency in Western US forests. And with this figure, I had aggregated data from these historical timber inventories that were taken in the early 1900s in the Southern Sierra Nevada. And what we did is we defined resiliency within the context of competition. So in this case, we quantified competition as relative stand density index. And for those who don't know what stand density index is, or SDI, it's just essentially a standardized way of quantifying competition based on tree size and density, so that you can make comparisons across stands of differing structures and compositions. So in our case, we divided it up into different forest types. Here we have pine mixed conifer, where the forest is predominantly dominated by pine in terms of percentage of basal area. We have xeric mixed conifer, which is essentially not dominated by pine or firs, which firs would dominate the mesic mixed conifer in that right panel there. And what we did was we aggregated that data and looked at relative SDI historically. So these inventories were taken in 1911 versus FIA data from 2011. Oh, I'm sorry, not FIA data, F3 data, which is a remote sensing project from the Forest Service, or product from the Forest Service. And so we quantified basal area from 2011. And so when you categorize competition in this way, based on relative SDI, you can break them up into these different, what we call management zones or competition zones. So essentially on the right axis, you can see that I have these different intervals that are shaded with these gray boxes. And so the white box, which goes from 0 to 25, that means 0 to 25% relative SDI. That means that that zone is free from competition. From 25 to 35, that means that that stand is experiencing partial competition. From 35 to 60, that means that that stand is experiencing full competition. And then beyond 60, that's where we get the zone of imminent mortality. So essentially, that stand is highly vulnerable to the density-dependent mortality processes that we would expect with competition. And so what we see here is that historically, these stands were composed of very, very low tree densities. I mean, essentially, most of them are either partially or completely free from competition, which means that they do not function in terms of mortality processes from these like competition or density-dependent mortality processes that we typically see in these forests today, right? When we think of things like drought, wildfire, insect outbreaks, a lot of the times it's because of competition, right? Whether that's stress induced or it facilitates, like, let's say like beetle travel, right? Beetle behavior. Obviously crown connectivity with wildfires, ladder fields, you know, vertical and horizontal continuity and things like that. That's all tree density related. But historically, that was not typically how these mortality processes were driven. And so we look at this and we think, okay, well, if this is what a resilient forest looks like, how do we implement this on the ground? Here is another sort of example, kind of almost building off of Malcolm's paper. This was a paper that I led and was published that same year, a couple of months after the operational resilience paper came on. But I wanted to look at, okay, well, we have these really cool, you know, inventories from the Southern Sierra. What does this look like across the entirety of the Sierra Nevada Southern Cascade region in these fire-prone mixed conifer forests? And not necessarily from a relative SDI, not through that lens, but really looking at things like tree density, basal area, species composition, and carbon, because carbon is becoming very, very important when we're talking about management. It's hard to talk about forests these days without talking about carbon. And so we wanted to see, do these certain objectives, like let's say fuel hazard reduction or carbon sequestration and storage, does that align with what we would expect of a resilient forest? And so we have these other historical timber inventories, again, taken from the early 1900s, where we were able to extrapolate those historical resilient conditions, what they look like historically. But it was really cool with this paper because we were able to also project what types of forests were favored given future climate. So between 2040 and 2069, what that would look like and what the difference is between historical and future conditions, to get a sense of, does historical conditions actually align with future resiliency? And if not, then where is it that we need to make those changes? And so in this slide, I actually have tree density here. We quantify a bunch of different things, as I mentioned, but I'm just showing it here to give you a sense of what I'm talking about when I'm saying preparing for future resiliency or future conditions under climate change. So here in this panel A, what we see is tree density across the Sierra Nevada Southern Cascade Range, where these are the fire-prone mixed conifer forests. And what we see is that a large part of the landscape was composed of low tree density. No surprise there, because we found that in Malcolm's paper. And we see it in the other historical timber inventories that we incorporated in this data set. So, in fact, more like 85% of this entire landscape was composed of less than 75 trees per hectare. So not a lot of trees on the landscape, very different than what they look like today. And we actually see in the future that as conditions are projected in California to actually get hotter, we see that now 99% of the landscape can actually only support less than 75 trees per hectare. So even lower tree densities will be more resilient to these projected climate conditions. And so that means that about 78% of the fire-prone mixed conifer forest in the Sierra Nevada Southern Cascade region is going to have will be unable, how do I word this? Will actually be able to, won't be able to support the same amount of tree density than what they did historically. So what this is saying is that 78% of the landscape will actually support less tree density than what it did historically, which is pretty astounding. And so when we look at these resilient characteristics, again, things like very, very low tree density, higher pine dominance, low amounts of carbon, low amounts of basal area, what does that mean in particularly for management? And so you'll notice that when I've been talking about these studies and other studies that I've done looking at things like the effects of thinning and prescribed fire on drought resistance in trees and to bark beetle outbreak, other sort of historical reconstructions or trying to figure out resiliency for the future, a lot of the times what we do is there's a heavy focus on resistance as a key component of resiliency and not so much really the recovery part. So things like regeneration stuff. And so there is kind of this huge knowledge gap, at least in my area of research, the contribution of things like seedling establishment, seedling success, how much of those are actually recruited as mature overstory and things like that. Or things like after a disturbance, how much does a tree grow and does it, recover to like the same growth rates that it had pre-disturbance, right? Like let's say example, like a fire came through, damaged the crown such that there's little crown left, or damage to the root system or the actual tree cambium. Can we expect that tree to actually recover from those injuries and is able to thrive, so many years post-disturbance? And those are things that I definitely want to look at because I know that it's, again, another component of like the resiliency sort of aspect. But I think the reason why we focus so much more on the resistance part of resiliency is because what I believe is that it's just, and this is just kind of like an idea that I've been sort of like exploring lately and like want to continue to explore as I move on in my research, is that resilient forests, at least historically, when fire was a main driver of ecosystem integrity, that resistance was actually more important than recovery. And, when you think about it for a second, if fire was frequent fire, then we would assume that fire intensity was low enough for most of the overstory to survive and maintain growth after fire. So there would sort of be a little need for regeneration due to the lack of mortality, right? To sustain those populations. Again, the caveat would be that it would occur, but in these small isolated pockets of high severity, but still not a major component of how that system looks and how it functions. But this is very, very different than how our forests function now, right? Now we have forests that are highly vulnerable to large-scale disturbances. And so we have to shift our focus more so now to the recovery than the resistance. And I'm not sure if that makes sense, and people can ask me questions at the end of the webinar, but that's kind of how I've been sort of thinking about, well, how do we move forward and working with the conditions that exist today? And there's just a high likelihood that we're going to have to really focus more so on the recovery aspect, because at a landscape scale, to make these forests resistant as they historically were would be a big undertaking, right? Due to limitations and funds and workforce and capacity and infrastructure. To make things truly resistant as they were before, I think is a little impractical at this point, or I just kind of don't see it really happening. So we're going to have to really focus more so on the recovery, and then there's that research gap to understand, okay, well then what does that mean? And so again, how do we reconcile this divergence and how fire-prone forests respond to disturbances, and how does this essentially change our management? And so I think it's really important that even if you're not working in mixed conifer forests, to again apply these sort of same ecological principles or considerations. Really, what is the ecosystem that I am working in? Does it function under high resistance? Again, kind of going back to this sort of arrow here, this spectrum. Do I have those conditions that facilitate, resistance even after a fire, or to facilitate regeneration after a fire? And so if you do, that's great, but that typically doesn't happen. And so if not, then what do I need to do to set it on that expected trajectory, right? To be resistant, or to, rely on high recovery. And so do I need to implement mechanical and prescribed fire treatment so that I can lower fuel hazards and maintain or promote growth? Or do I need to focus my efforts on setting myself up for replanting if it's not possible to achieve a truly resistant state given my resources? Do I even want to keep on that trajectory? I think that's a really important question. Is that trajectory even appropriate at all, given the conditions that I expect with climate change, right? Or should I change it? And so, for example, like reaching for that lower end of or below the natural range of variation, like I showed in that study that I did looking at the entirety of the Sierra Nevada Southern Cascade region. While it shows that restoration treatments may be effective under climate change, there are going to be some areas where you're going to have to even go more drastic than that to adapt to those climatic conditions that are expected under climate change. And so, or, another good example, I do a lot of research in giant sequoia, and especially given the recent wildfires, recovery of giant sequoia in these high severity areas. And there's a lot of talk about, do we actually, use assisted migration with this species? Should we be planting further north? Because it seems like it's going to be really, really hard for these populations to recover where they have already burned in the southern end of their, in their range, especially at the southern end of their range. We're seeing, instances of regeneration failure, and we don't have enough resources to replant those groves and get them back to what they were. So do we now determine, okay, maybe we actually need to move these groves somewhere else, or move sequoia somewhere else? And again, it's because we don't necessarily see that ecosystem that exists today to function the same way that it does in the future. So those are questions that you have to ask yourself. And we also have to accept the inherent conflicts between our own objectives for that forest and what is resilient to future conditions. For example, again, referring back to that landscape scale paper, when you have less trees, right, on a landscape, from a carbon perspective, that doesn't seem really great, right? If I'm trying to get into the carbon market and achieve carbon credits for my forest, less trees isn't really good, right? Because that's less carbon on the landscape, less biomass on the landscape. And so, you know, from that perspective, it's bad, but I know that that forest then is in a more resilient condition. There's an inherent conflict there, right? So how do I prioritize how do I achieve my objectives, but also still ensure that this forest is sustainable over time? And again, so it's like this balancing act and trying to find that optimization. And so, you know, another example of that too is like, let's say I want to replant a bunch of trees, right? So I can repopulate a stand. For example, like in the giant sequoia groves, do I have the resources to thin out that forest as it matures so that I can limit competition to drought? That is something that we're also struggling with right now. I'm working on a project where we're looking at giant sequoia replanting density and what that means in terms of shrub development, fuel hazards, soil conditions, and things like that, and whether or not there is this trade-off between how many trees we plant on the landscape and what can actually survive there. And so managing for resiliency can be a pretty daunting challenge, but you know, we can do it. The tools and knowledge and information that are available, you know, it's all available there. It's just a matter of weighing these sorts of trade-offs between what is ecologically viable and what we want to get out of our forests. Yeah, and with that, I will open it up for questions.
Thank you so much, Alexis. That was awesome. And
Yeah.
it's just so relevant.
Yeah, thank you.
Okay. Does anybody have any questions? I have a question.
Yes, please.
So you mentioned a lot of these internal conflicts that landowners are likely facing between fuels reduction and managing for climate change and managing for carbon. And you're right, it can seem, it is very daunting. Do you have any recommendations for resources where landowners can learn more about how to make that appropriate decision and how those decisions or what information they can use to make their own decision? Because sometimes a lot of the landowners I've interacted with have basically said, I feel lost.
Yeah, I think that, well, one of the organizations, so the UC Agricultural and Natural Resources, the Cooperative Extension Program, I feel like is a really, really great source of information in terms of the research that is out there and bridging that with management and like interfacing with the community. So I would say that that's a really good resource. So they provide a lot of webinars and workshops and things like that, where people can, from a person, like a non-researcher perspective, understand how we can apply that on the ground and sort of weigh these options and figure out what's best for us. So I really recommend them as like as a source for information, especially when it comes to applying research to actual management of land. I would also say too, we do have the California Fire Science Consortium, which is also sort of like a network of like researchers and such. But what we do is we distill that research into like science briefs and workshops and webinars and stuff like that, where again, we help managers understand these options and understand the trade-offs and stuff. So that's another really great website to follow and look at. They have an emailing list, and I think they're amazing. And they're also based out of the Stevens Lab, and so they're doing a lot of really great work to communicate with managers.
Awesome. I'm Googling those things and I'm going to stick them in the chat
Yeah,
for any of the folks listening. And then Benjamin, are you able to turn off
Yeah.
mute and ask the question? If not, no worries. And
No, yeah.
oh, go ahead.
Yeah, no. I was going to say, actually, that's such a great question because I had that as part of my presentation originally, but I wasn't sure how fast I'd get through this. And so I was like, oh, no, I'll cut it. And if someone asked me, I'll talk about it. So thank you, Benjamin, because I think it's a great question. Yeah, right. Forests, it's such a good point because forests are not these isolated islands, right? They're not, disturbances don't discriminate based on ownership. They don't understand property boundaries or any of that. And so it's a great point that if you're a small private landowner, you have a few hundred acres, but like, let's say you have Forest Service land juxtaposed against your land and it's thousands of acres of untreated forest. What can you do, right, to make your area more resilient? Because it may be that like no matter what you do, it won't be at least resistant, right? Like if a fire were to come through, it's likely that you have like high levels of mortality. In an ideal world, I wish that we would have more collaborations across different ownerships to make our forests more resilient at a larger scale. But the pace and scale of that is lacking, and it's not keeping up with the changes that are happening in these forests, with the frequency of these disturbances, the intensity of these disturbances. There are some projects and some success stories. For example, in the Creek Fire, there were some huge fuel breaks put in across Southern California Edison, which is an energy company that has private forests that was within the Creek Fire, and the Forest Service and CAL FIRE. So state, federal, and private agencies worked together to create these fuel breaks, and they were pretty effective, which is amazing because that was a pretty devastating fire. So there are success stories where that happens, but it doesn't happen very often. And so I think your concern is totally valid. What I would say to that is then you would have to consider the high likelihood that let's say all of your acres are gone. Then how do you prepare yourself the best way that you can to recover from that, right? So are we planning ahead again for replanting, or anticipating that maybe we're going to have to, instead of what we would typically thin out our forest for whatever objectives we have, maybe we create these strategically placed like huge fuel breaks, which nobody really wants to do on their private forest land, right? But that may be necessary in order to withstand or mitigate some of that fire behavior. So again, that's a trade-off, right? Like let's say your private land is you're extracting for timber, that's your objective. You may have to forego some of that in order to create more defensible space so that your property can be maybe protected from juxtaposed unmanaged land. And definitely plan for replanting, probably.
As a follow-up question to that, Alexis,
Yeah.
so that planning process, if folks are like, okay, I'm super limited on resources, I don't have the money or the bandwidth really to prepare my property. I understand that like it's not if, it's when a wildfire comes. But in order to do that planning process and like I guess, what does that look like? Like if you're planning for recovery.
If you're planning for recovery, so what I would do is I would think about, okay, so what are the future conditions going to be for that site in terms of climate, because that'll tell you a lot about what the disturbances are going to be, right? If it's getting hotter and drier, you might have more fire, definitely more drought, more insect outbreaks and things like that. And so when you look at the climate, just determining, okay, well, what is expected in terms of disturbance? Because if I'm anticipating that some of the stuff is going to, these disturbances are going to kill some trees, then what kind of trees do I plant, or what is the density that I plant at, right? Because typically, you know, we plant at these pretty high densities expecting a lot of seedling mortality in the first few years, but maybe you actually want to plant at a lower tree density, right? To limit that amount of competition so that these trees are free to grow, they're more vigorous. And so when it gets hotter and drier, they may be able to withstand that drought, or they may be able to withstand that bark beetle attack. Another thing that I found in one of my studies was that prescribed fire helps to build up defenses in pine trees, which is typically the trees that we favor, right? When we think of fire adapted or fire resistant forests. So, you know, you could, if maybe prescribed fire wasn't part of your plan, but it could be now, right? As a way to like up the defenses in those pines. You know, when you plant at a lower tree density, that's less biomass on your site. So in the long term, you'll have less fuels and things like that. And again, with prescribed fire too, you'll have less fuels over time. So those are things that you have to think about. And so it's kind of like, what are the future conditions? What kind of disturbances can I expect with those conditions? And based on the disturbances and how they act, then what is sort of the best sort of structure and composition to withstand those disturbances? Or, you know, like, and again, like, what would I need to plant? What kind of species at what densities and those sorts of things.
Perfect. Okay, awesome. And then I do know, Katie, I know you're online. Do you have anything to add as somebody who's kind of functioning locally in that role? Kind of, I feel like we're all on a spectrum, right? It's like we have Alexis, who is doing a higher level research, which is helping to influence, I think UC Cooperative Extension, which helps kind of do that management private landowner interface. Do you have anything else to add, Katie?
Hi, thanks. Great talk, Lex. Disclaimer, Lex is a great mentor and former lab mate from Berkeley. I love working with her. So for those who don't know me, I am the statewide coordinator for UC Agriculture Natural Resources Fire Network. I'm based out of the Placer, Nevada UC Cooperative Extension office in Auburn. And I just want to echo what Lex said about using our programs as a resource for private landowners in the Sierra foothills. We offer a lot of great workshops and forest stewardship, wildfire, defensible space, home hardening, that type of thing. And we're hoping to bring all those nice workshops to the Sierra foothills in the coming years. But I think if you have questions, feel free to always reach out to our office or also to researchers at the universities like Lex or who obviously do a lot of great work in these areas. And part of the joy of working in Extension is we get to work with researchers like Lex, distill their research down into little fact sheets and things and share it with landowners. So again, great job, Lex. That's all I have to add.
Awesome. Thank you, Katie. Does anybody else have any questions? And Katie, could you throw that workshop series into the chat box? And then also a quick plug, the Placer PBA works closely with Katie, and I know she's also working with other PBAs in the region, or prescribed burn associations, excuse me, for those who are interested in adding the prescribed fire as a tool. Oh, and then the Eastern Nevada County Truckee area is also always joining prescribed burns. Darren's our frequent flyer for most prescribed burns, which is awesome. So anyway, there are tons of resources available. If you guys have any questions, Lex, is it okay if you throw your contact information in the chat in case anybody, they digest some of this information and then have some questions later? Oh,
Yeah.
and Theo, I see your hand. Please feel free to unmute.
I've unmuted, and I'll feel free to ask a question too, I guess. I don't, controlled burning is not an option for this. It's just a 6-acre parcel, and pine trees. There's a lot of deep litter, and raking is not something we want to do either. I know if we we're going to prep it for a controlled burn, we'd rake away a few feet from the base of the trees in
Mhm.
a hot, dry, windy fire, would that be helpful enough to reduce tree mortality from like the long residence time from like 8 inches of organic matter?
Yeah, that's a good question. So, are you mostly working in pine? Is that what's on your acres?
It's mostly pine, but there's actually a lot of pockets of oak leaves too, which really make it pretty rough.
Yeah, pretty flammable. It's kind of funny because I just bought a house in Mariposa and I have the same. I'm on 6 acres and it's pretty much the same thing too. I have a lot of oaks and a lot of grasses and stuff, and so it's something that I'm trying to figure out myself. And so I'm actually working with the local PBA, the Yosemite Gateway Prescribed Burn Cooperative, which covers Mariposa, Madera counties. And so I want to do a burn here. One, because I just think ecologically it's valuable. I just want fire on the ground because the oaks are indicative of that existing there quite frequently. And then also too, from the fire hazard standpoint as well. So it kind of depends. So like if you have pretty high canopy base height, meaning the amount of distance between the fuels on the ground and the base of the living part of the tree, if that is big enough, then having duff and stuff like that may not impact at least the crown injury. You may not get fire up into the crown, but as you mentioned, Theo, yes, you can get sort of long residence heating. And so one thing to do is, yeah, rake it back. That the caveat to that is like during especially years of severe drought for pines, at least this was found in southeastern pines, is that even when you do a prescribed burn and you do even do some raking and stuff like that, you can actually still cause a lot of root damage to those trees and can kill them. But if your pines are large enough, they should be pretty resistant regardless. But I wouldn't count prescribed burning out. And I don't know if you have a local PBA that could assist you in doing that. PBAs are great because they will, go through a smoke management plan with you and a fuel hazard reduction plan with you, and walk you through what needs to be done. But I feel like it's the best way to do it. And we burn typically when we're doing a prescribed burn, especially in private land, it's always on the most conservative, moderate conditions, really, because we are afraid of, we don't want to damage anything. We don't want to kill trees, but we also don't want the fire to burn too hot and there be any sort of risk of escape. And so when you're burning under those conditions, prescribed fire is very, very safe, actually, and very effective. So I wouldn't,
here,
you can do it if it's possible.
Sorry, just to jump in so you don't have to, it's, yes, all of that. We just don't have it as an option legally in the city limits where we are. So
I see.
We're working on that front too, because it's the best, but until then, just trying to figure out. So with the raking, would it be like looking at roots, actually like tearing the feeder roots, or would it be like more about exposing them to more heat from less duff,
Yeah, no. So the duff itself, if you have a deep duff layer, what that does is it actually traps heat, especially when you have oak leaves or pine needles, because there can be a lot of air pockets actually within that duff layer. And so you can keep heat in there for a very, very long time. And so it's the heat that is staying there that is actually what's causing the killing of the roots. And so you can take that duff layer back, and then that way it can protect the cambium of the tree and maybe protect the roots. And so that's what the raking is essentially doing. It's just removing that layer that can trap heat and keep that heat there for a long time. It's not necessarily like any sort of like flaming combustion or anything that's happening there. I don't know if that makes sense.
Yeah, that's really helpful. Thanks. And do you know, with the southeastern pine you were talking about, is that root damage, like direct root damage, or more like root damage from taking away mulch?
It's the root damage from the heat from the duff layer. And so it was just enough heat to ruin the structural integrity of the roots. And so what ended up happening actually was that they became less vigorous. And so because there was sort of like that heat damage to the roots, they weren't able to uptake water and nutrients. And so as they were photosynthesizing, it wasn't as efficient. And so they became less vigorous over time, which made them more susceptible to things like bark beetles, I think, which was ultimately what ended up killing those trees.
Thank you. Super helpful. All right.
Yeah.
Appreciate it.
Mm-hmm.
Ron, I'll just read your question. It's in the chat, but please feel free to chime in if we need any clarification. So Lex, any data or thoughts on existing populations of Pacific madrone, particularly in prescribed fire burn units mixed with conifers and oaks? Do you mean conserving those species, Ron? Any thoughts on it, just as it's stated, yeah. Alexis?
Yeah. So I love madrone, so I'm saying to conserve it. I love madrone. I think they're just the coolest hardwood. They're my favorite hardwood. But yeah, they kind of, you know, it's like a manzanita, right? It's in the same family, and so it kind of burns hot like a manzanita. And when a fire comes through, it's usually top killed, but sprouts like pretty vigorously following fire, similar to oaks. And a lot of times where I've seen madrone is in these areas where you have conifers and oaks. And so I think that if you're trying to promote them, you know, prescribed fire is a good way to do that. They're adapted to that environment, but they're also adapted to high severity fire as well. So you may see some sort of like land type conversion if you want to promote conifers and all the conifers are killed, then, you know, you may get more madrone, but you also may get more oak too. And that's kind of like the interesting thing, especially like in the sequoia groves that I'm looking at, where we see pretty high severity. Almost all the trees are killed, including the large sequoia. It's kind of interesting because what's coming back may not be the sequoias, but it's like the oaks and the madrones and stuff. And what that tells me, especially when now I can see all the trees because there's no foliage left, so I can see all the trees, there are these very large, beautiful oaks and madrones. And so that tells me that that was actually land that was managed by indigenous people for oaks. And so kind of converting it back to what it really was is kind of an interesting thing, and is actually more adapted to hotter, drier conditions and higher severity fires. They may be the winners under some conditions. And so I think it's a good thing, yeah, Ron, to keep in the mix, because I think that they're going to thrive under some of the conditions that we expect with climate change. And obviously, yeah, you do want to be considerate of the amount of heat that can be caused by these madrones, right? Because they can burn very hot. But I think that if you're promoting them so that they are, you know, not necessarily like these like small bushes of madrones, but you're actually making them into like the tree form, I think that they can be like a pretty good component of the landscape, even with like the fire aspect of it. And even in some cases, probably more resilient than some other species. Yeah, that's cool that you want to keep them in the mix, because I love them.
Awesome. We have 3 minutes left. Anybody that's waiting till the end to speak up? Alexis also graciously put her email in the chat box for anybody that does want to follow up or has any specific questions. Just want to finish by saying thank you so much, Lex, for coming out and speaking to the group. Really appreciate it. I think you're working on some incredible stuff that I think is definitely having really positive influence on our management in the Sierras particularly. So thank you so much.
Yeah, no, thank you for having me. Like I said, I love this kind of stuff. And please, yeah, if you have questions, or even if you just like want to talk about stuff, for stuff, shoot me an email. I love it. I love it. And please do.
Awesome. Thank you guys, everybody. We will see you soon. Just stop recording.